Bismillahirrahmanirrahim. Assalamu alaikum dear students. Today we have to solve some problems related to capacitance of a capacitor. It is chapter number 25 in the 10th edition of Halliday, Resnick and Walker's Fundamentals of Physics. So problem number 1 is, statement is, the capacitor in the figure I will show you later has a capacitance of 25 microfarad and is initially uncharged. The battery can provide a potential difference of 120 volt. After switching on the switch S, how much charge will pass through it? So this is simple question about the capacitance of the capacitor. So let's solve it. This is the figure which was given in the mentioned in the problem statement, and this is switch. When this switch is closed, this battery can provide a potential difference of 120 volt between the plates, because this plate is connected to positive, this is to negative, so the potential difference of 120 volt we established. So this capacitor will be charged to a maximum amount of Q. We have to find that maximum amount. Okay. The given data is capacitance is given as 25 microfarad. I will write it 25 into 10 raised to minus 6 farad, because farad is the SI unit, and the V is 120 volt. We have to find Q. The formula here to use is Q is equal to CV. We put the value. C is 25 into 10 raised to minus 6 into 120 is value of V. So we multiplied. When we multiplied 120 with 25, it gives us 3000. So answer will be 3000 into 10 raised to minus 6 coulomb. Or if you remove these 3 zeros, it will give you 3 power 10 power 3 will be added here. So we write here 3 into 10 raised to power 3 minus 6. 3 minus 6 is minus 3. So answer will be 3 into 10 raised to minus 3 coulomb, or minus 10 power minus 3 you know is micro. So answer will be 3 micro coulomb. So when this switch is closed, then a charge of 3 microcoulomb will pass through it. Maximum charge stored on the plates of capacitor will be 3 microcoulomb. That's it. That's the answer of the question. So next second question. Second question is, statement is, the metal two metal objects are shown in the figure as there are any two objects. The figure is, we can say this is an object and this is an other object. These are two objects, these are here. So these two objects in any form, when they are separated by small distance and charged to same amount with negative opposite charges, then they constitute a capacitor. So they will constitute a capacitor. So net charge of 70 picocoulomb on one capacitor, one object, and negative 70 picocoulomb on the second. That is, they are the two plates of the capacitor with positive 70 picocoulomb on the one plate and the negative 70 picocoulomb on the second plate. So they constitute a capacitor. Question is, when they are charged this amount, then it is obvious that there will be a potential difference, and that potential difference is of 20 volt is established between them. So question is, what is the capacitance of the system? So we have to find the capacitance of the capacitor. Charge is to 70 picocoulomb and the potential difference is 20 volt. Q and V are given. We have to find C. This is A part. B part is, so first we solve this question. First part. So charge is 70 picocoulomb. We write it 70 into 10 raised to minus 12, so pico is 10 raised to the power minus 12. So Q is be 70 into 10 raised to the power minus 12 coulomb. And V is 20 volt. We have to find C. The formula to use here is again Q is equal to CV. So when we make C the subject of formula, we shift Q here, V here, and we will divided. So C will be equal to Q over V. So put the values. C is equal to Q. Q is 70 into 10 raised to minus 12, and V is 20. So 70 over 20 is 3.5. So capacitance will be 3.5 into 10 raised to minus 12 farad, or we can write it 3.5 picofarad. That's it. Okay. So next is B part is, if the charge are changed to 200 picocoulomb, what does the capacitance become? So we know that capacitance depends upon the material. For a given capacitor, it will be same. It will be same. If the separation, because we know this formula of separate capacitance is epsilon naught A over D. For parallel plate capacitors, if the plate's area and separation remains unchanged, capacitance will remain unchanged. It doesn't depend upon charge. So answer of the B part is the capacitance will remain unchanged. The C part is, what does plate potential difference becomes? Potential difference that will be changed because Q is equal to CV. C is remain constant. Q is charged, so C will V be obviously changed. We check it how much it will change. The question is V is equal to Q over C. Put the values. Now Q is 200 because we given 200 into 10 to the minus 12 over C is 3.5. C unchanged. C is 3.5 into 10 to the minus 12. So when we solve it, 10 over minus 12 is cancelled with 10 power minus 12. So 200 over 3.5 gives us 75.14 volts. So now the potential difference between the plates would be 57.14 volts. That's it. I think that's enough for today. Next question number 3, 4 and 5 will be solved in the next video. So stay tuned. I hope you like this video. If you like it, please like, share and subscribe to my channel if you're new. Also press the bell icon so that you can get all the notification of my coming videos. See you in next video very soon. Until then, Allah Hafiz.